Assalamu alaikum friends, my name is Rabia Wasim and I'm from Department Peace Biotechnology, and the topic of my presentation is the chemistry behind lightning after rain. So to understand the concept of the chemistry behind lightning after rain, we need to firstly know that what is lightning. Lightning is the light we see sometimes after the rain, and you might have seen this light even during the rain. So the question arises, what is lightning? Lightning is a naturally occurring electrostatic discharge during which two electrically charged regions in the atmosphere or the ground temporarily equalize themselves, causing the instantaneous release of as much as 1 gigajoule of energy, and we see this 1 gigajoule of energy in the form of a lightning strike. So let's take a look at how lightning happens. And for your information, the scientists' understanding of the full process is still patchy in places, but we do have a relatively good general ideas about the whole process of lightning. So the basic idea behind the lightning is the electrification. Electrification is the action or process of charging something with electricity. So according to the concept of electrification, a body can be charged or discharged by the transfer of electrons. So the main charging area in a thunderstorm that causes the lightning occurs in the central part of the storm where air is moving upwards rapidly. That updraft causes the temperature to fall down. That the temperature ranges from -15 to -25 degrees Celsius, which means 5 to -13 Fahrenheit. Lightning causes the thunder, that sound we hear sometimes during the lightning. That sound is because of the lightning process, the lightning genesis. That is a sound from the shock wave which develops as gases in the vicinity of the discharge experience a sudden increase in pressure. Lightning occurs commonly during thunderstorms and other types of energetic weather systems, but volcanic lightning can also occur during volcanic eruptions. That is a different type of concept. They produce a wide range of electromagnetic radiation from very hot plasma created by the rapid movement of electrons to brilliant flashes of visible light in the form of black body radiation. But this concept is not to be discussed here today. We're here to understand the concept of lightning and the whole process of lightning genesis. Inside a thundercloud, cold temperatures and air updraft provide perfect conditions for lightning genesis. Now, lightning genesis is the process of the production of the lightning. Small, supercooled droplets of water get carried upwards in the cloud by the updrafts along with small ice crystals. Blobs of denser soft hail called graupel are comparatively unmoved or moved downwards. Graupels are the small particles of snow with a fragile crust of ice, which is also known as soft hail. So this lightning genesis occurs in the troposphere. According to the atmospheric chemistry, the troposphere is an oxidizing medium. The dominant oxidizing species in the troposphere is hydroxyl radical, which is OH, and virtually all organic compounds, carbon monoxide, CaO, methane, CH4, and mostly nitrogen and sulfur containing species react with the hydroxyl radical in the atmosphere. So this lightning genesis occurs in the troposphere, and oxygen is also present in the atmosphere, in which lightning strikes split the diatomic oxygen present in the air into individual atoms of oxygen. These individual atoms of oxygen then combine with other oxygen to form ozone. This is the reason why we can smell lightning. Some chemistry about lightning says that when lightning occurs, sometimes you can smell it. Intense heat and electrical current produce mini chemical factory where O2 and N2 are broken down into ions. Some reform into O2 and N2, but a significant number form nitrous oxide compounds, which means that O2 plus N2 can be converted into NO or NO2 by the electrification process and the high intense heat from the lightning. When the electrification process occurs, the lightning ionizes air molecules in its path. The blue-violet color of the lightning is a result of the light emissions from excited nitrogen and hydrogen atoms. So the color that we see during the lightning is due to the chemistry, or we can say the atoms of nitrogen and hydrogen present in the air, which are ionized and excited, and they produce these colors like blue-violet color of the lightning. Now let's talk about the role of nitrogen in the atmosphere during the lightning. Nitrogen is also involved in further lightning chemistry. At the high temperatures lightning generates, there is enough energy for nitrogen and oxygen in the air to combine, forming nitrogen oxides. In turn, these nitrogen oxides can dissolve in the rainwater and form nitrates, which are important for plant growth, and they are important for chemical balance of our ecosystem. The process of this lightning and the conversion of nitrogen into nitrogen oxides is a really very vital process for plant growth and for our food. The process of usually unreactive nitrogen being turned into nitrates that plants can use is also called as nitrogen fixing. Lightning accounts for up to 3 to 10 teragrams of nitrogen fixed per year compared to the 100 to 300 teragrams fixed by the bacteria. Now that's a good value. Now talking about the tropospheric chemistry, as I talked before, troposphere is a part of our atmosphere, and the chemistry is changed during the lightning. So before talking about the tropospheric chemistry during the lightning, the characteristics of troposphere are that it is the first atmospheric layer closest to the Earth's surface. The troposphere is a region where weather occurs. The temperature of the troposphere decreases with an increase in height, and the troposphere makes up approximately 75% of the Earth's atmosphere by mass. So from this you can analyze that troposphere is the most significant layer of atmosphere for human beings and for other living organisms. So during the lightning, the two primary gases NO and NO2 are formed during the lightning discharge when the air is heated to 30,000 degrees inside the lightning channel. Since air is made up of approximately 80% of nitrogen and 20% of oxygen, these molecules break up into nitrogen and oxygen atoms. So the science of the thunderstorm says that air updrafts in storm clouds carry small water droplets and ice crystals up, while denser soft hail falls. When they collide, ice crystals become positively charged and soft hail becomes negatively charged. Consequently, the cloud's top becomes positively charged and its base becomes the negatively charged one. So, the cloud's negatively charged base repels the electrons on the ground. Cloud to ground lightning is one type of lightning. Others also result from the charge differences between the clouds that will be discussed in the next section. And also there is the temperature is 30,000 degrees Celsius, and the lightning causes rapid heating and expansion of nearby air, followed by cooling and contraction. This creates a sonic shock wave, which is known as thunder. Now to the basic concept of my presentation, that what is the chemistry behind lightning. Lightning strikes can split diatomic oxygen in the air into individual oxygen atoms, as I discussed before. These combine with the other oxygen molecules to form ozone, giving rise to the pre-rain smell. That smell occurs due to the formation of ozone. That ozone has a pungent smell. Lightning ionizes air molecules in its path. The blue violet color occurs during the lightning. That is due to the emission of the excited nitrogen-hydrogen atoms light, and at the high temperatures, lightning generates nitrogen and oxygen, and it combines to form nitrogenous oxides that also plays a role in nitrogen fixation, and it is good for the plant growth. So as we know that lightning occurs due to the charge differences between the base of the clouds and the Earth's surface, but how do we know that lightning is a chemical or a physical change? Let's discuss it now. Lightning is a chemical change. Lightning is also a physical change, but some say that lightning is only a physical change. Lightning is both a physical and a chemical change, as no new substances that are formed during this process, so it can also be termed as physical change. Some people say that it's only physical change, but the chemists disagree to this statement, and they say that this chemical change is the reactions of protons and neutrons in the cloud, so it is also referred as a chemical change. So we can say that lightning is also a chemical change, but we cannot say that it's not a physical change. To clarify this, I have an example, which is lighting a match. Lighting a match and letting it burn is an example of a chemical change. Chemical reactions cause chemical changes in a chemical reaction. Two or more substances usually called as reactants form different substances called the products. So if we see in the lightning, some of the reactants in the air convert into the products, into the new products that are usually good for living organisms and the atmosphere and the ecosystem. So we can say that lightning is also a chemical process. Now we're heading towards the most basic understanding of lightning, which is the type of lightning. Types of lightning helps us explain the process of lightning. There are three primary types of lightning, which are defined as the starting and defined by the starting and the ending points of a flash channel. These three are the intra-cloud or in-cloud lightning, cloud-to-cloud lightning, and cloud-to-ground lightning. Intra-cloud lightning, the most common type of lightning, is known as the intra-cloud or in-cloud lightning. It happens completely inside a cloud, jumping between different charge regions in the cloud, and it is not related to the surface of the earth. Intra-cloud lightning is sometimes called sheet lightning because it lights up the sky with a sheet of light, and it's so beautiful. The next type is the cloud-to-cloud lightning. It is also known as CC lightning or intercloud lightning. Spider lightning refers to long horizontal moving flashes often seen on the underside of a stratiform clouds. Not to be confused with intracloud lightning, which is within a single cloud. This cloud-to-cloud lightning is between two or more than two clouds, which produces flashes of lightning, and it ends between two different thunderclouds, which are the functional thundercloud units. The next is cloud-to-ground lightning, which is also known as the CG lightning. Cloud-to-ground lightning is a lightning discharge between a thundercloud and the ground. It is initiated by a step leader moving down from the cloud, which is met by a streamer moving up from the ground. CG is the least common but best understood of all the types of lightning, which shows that electrification occurs and two channels of positively charged and negatively charges repel each other, which produces a shock wave. To add to your information, there is a ball lightning, which is the rarest type of lightning, which is a phenomenon described as a floating illuminated sphere that occurs during the thunderstorms, but it is rarely seen. Cloud-to-ground lightning is also dangerous for the humanity and the people and the living organisms living on Earth, because this flash of lightning touches the ground and it can also burn the things around it. Talking about a simple concept, that is the smell after the lightning. Even if there is barely any lightning, there are still trace amounts of lightning produced ozone and nitrogen dioxides in the air scattered about the storm. When the gust front of a storm carries it out ahead of the rain, you can smell it before it's scavenged to the ground. You may just be smelling lightning. So the smell after the lightning or the smell before the rain is due to the process of lightning, which causes the oxygen to deplete into single oxygen atoms, which combine with the other oxygen to form ozone. What is the 30-30 rule for lightning? There is a 30-30 rule for lightning, and don't forget the rule. After you see the lightning, start counting to 30. If you hear thunder before you reach 30, go indoors. Suspend activities for at least 30 minutes after the last clap of thunder. Lightning affects the concentration of atmospheric gases that are important for the climate. So, in effect, that lightning affects the climate and weather changes. Chemical changes in the atmosphere are still surrounded by large uncertainties. The new package will help us to build better atmospheric models and climate predictions. The one studying the lightning can also explain what climate changes occur during the lightning, because the chemical changes occur during the lightning. The role of thunderstorms in our climate is important and significant, but we need to get more accurate data to estimate their influence on variability of the climate, says Torsten. And now talking about the display of light and energy during the lightning. Displays of light and energy is due to a reason, which I'm going to explain. High up in the atmosphere, the electrical discharges take many forms and exist only briefly, milliseconds at most. These transient luminous events include colorful phenomena with fairy tale names: sprites, blue jets, and elves. Sprites are the flashes caused by electrical breakdown in the mesosphere between 50 km and 100 km above the surface. They resemble reddish jellyfish with tentacles streaming down. The blue jet propagates upwards into the stratosphere from cloud tops. ESA Andreas Mogensen recorded a pulsating blue jet on camera for the first time during his mission to the International Space Station in 2015. Blue jets are the lightning discharges reaching upwardly through the stratosphere, and elves are the concentric rings of emissions. Don't confuse the both. Now you might know that how and why lightning occurs and what is the chemistry. Basically, my presentation was focused on the chemistry behind the lightning and what changes occur during the lightning. Lightning affects the concentration of atmospheric gases that are important for the climate. New data will improve our understanding of the effect of thunderstorms on the atmosphere and contribute to more accurate climate models.